Hey, so today I want to talk about RAGs and are RAGs still useful in the era of long context language models? So let's start with understanding of what RAG is. So imagine you bought a new set of Lego and you're going through, you open the box and there are small packages labeled 1, 2, 3, 4, 5, and now you open the instruction and there is a first step, which is take this piece out of box number 1. Okay, so you open the box, you put it on the ground, there are 20 elements, you quickly can spot the correct one, take it and start assembly, all right? So this is exactly what the RAG is. So imagine that you, instead of a box, set the box with pieces for one set, you get a container or a huge, massive Lego construction, 100 meters high and wide. And you're asked the same task, get this piece out of this construction. So now it's becoming difficult, right? It's almost impossible to do because it's so huge and you have to disassemble everything and to spot the correct piece, which take ages, all right? And your actual processing power is not fast enough to do it in the reasonable time. And the same thing happened kind of with LLMs. So imagine that in 2020, Meta released a paper about RAGs. So the problem, even 2 years ago with models, was that the input context, so what you provide as an input, is limited in size. Okay? And in order to fight with this limitation, you had to provide the most necessary information as to the input so it can give you the correct output, right? So let's imagine that you have one big document, okay? And in order to, and it's too big to put in the context of LLM at the beginning, right? It's I don't know, 1,000 pages long document. So what was figured out is that you can split this document into the smaller chunks, right? A little bit like with our Lego set, right? With smaller packages, 1, 2, 3, 4, 5. And if you do it enough times, then each chunk contains some info, okay? And what you now have to do is to put it in some data storage, and it's called, in our case, it will be a vector data store, because what we do, we have the understanding what this chunk is about, and we encode it in order to create a vector, representation of this chunk, okay? So imagine that we have our vector and it's 1, 5, 8, but instead of this it's 128,000 vectors long, like in number of parameters or whatever. And this chunk is basically represented, the content, the context of this chunk is represented, for example, as 2, 4, 5, okay? So now each of the chunk has its own representation, okay? And it happens for each of the chunk. And then we store this vectors in our vector DB, okay? And it's being stored in the vector DB, right? Vector DB. Okay, so what happens now is that the user creates a query. Query is being embedded as well into the, you guessed it, vector. So it's 4, 4, 5, all right? And now we retrieve the nearest, the most relevant chunks out of our vector DB based on vector similarity. So in our case, we would receive this chunk because it's quite close, let's say, because 4545, and this chunk would be added to the query to our LLM. And because it has all the relevant information inside of it, it can generate the correct answer, let's say. But obviously it has its own limitation. Have we taken all the required chunks? Or have we, embedded it properly and created vectors properly so we can get the correct values, correct chunks by themselves, all right? And there were multiple ways to improve this indexing. So how do we store our chunks, but also the query generation, let's say, or query translation. So how can we modify the query to ensure that we get the correct chunks? And there are different tactics in how we can accomplish that. Ending with, even the regeneration of the answer or whatever. But I will say a little bit more about it at the end. So now we have long context language models, which can accept, the whole document as it is, all right? With Gemini 2.0 Flash, I think it has 1 million token input. It's like, 1,600 pages. So you can put the whole trilogy of Lord of the Rings inside of the prompt. So, the context is quite long and the answers are really, really good. So now is the question of, do we even need our RAGs, right? Is it still relevant? Is it still important? And the answer is yes, but as always, right? We still, when we have a lot of data and we are trying to get the relevant answer, right? Sometimes we have to get the correct data anyway, because we don't want it to struggle to find the correct info in there. We want to provide as much as relevant info we can. But if you can imagine that on one side we have input size as a limitation, and then we have the relevance of info, of input, right? We want to be the most relevant input for the input size, right? But if the input size is bigger, our understanding of is it the correct input size, is it the correct input, how sure are we that this is the correct input, may be lower, okay? So we can provide more info, more chunks, more documents relevant to answer a given question in order to answer the initial query, all right? So what happens now is that, let's imagine that we have 1 million documents, right? And what we do is we summarize each document. So we have summary, 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 which contains all the relevant info for the whole document. And what we do RAG again, but instead of getting chunks, we are getting whole relevant documents and putting it into our input, right? We can now be much more generous of how much info do we provide, but still trying to ensure the high quality input is provided, especially if we are talking about so many documents and so many data that it's beneficial to be more efficient by ensuring the highest quality data is there, but we can be much more generous less strict with how many data we provide to limit the amount of mistakes we make during retrieval. And there are multiple tactics which we can take in order to ensure that the data we get is relevant, okay? So there are query transformations we can do. For example, we can do a step-back query manipulation. So a user asks, how is LangChain, creating a graph, right? So we can do a more abstract question based on it and get bigger amount of info. We can create multiple questions based on this one, which are leading to these questions. So first one could be what is LLM, what is LangChain, and so on, in order to get the biggest amount of relevant data out of our data store and put it into the model. And there are obviously different ways of summarization of our documents, how we can cluster them across different companies, problems, projects, whatever, right? So then it's all about basically ensuring that we are able to get the most relevant output from the input that we have, okay? And it doesn't matter, are you using RAG, are you putting everything in prompt at the beginning and always include everything? It's not deterministic. You have to use multiple ways, multiple methods along the way of ensuring that the quality of the output is good enough so it can be presented back to the user and was data in there. And it requires iteration, it requires like embedded unit tests or quality checks inside the code itself. So for example, an LLM validating the quality of other LLM output in order to get the most relevant info. Anyway, I hope it was useful, and if you would like to see more of videos like this, deep dives into AI, but also my understanding of management and leadership, make sure to subscribe, and I will see you next time.